Okay, so we're just going to finish off the 2019 practice exam. And so we got up to question 13 last time. So let's start with question 14 here. So we've got a geometric sequence, and that's got a second term of negative 2.5 and a sum to infinity of 8. And we want to determine the sum of the first three terms of the sequence. So right here, we've got two equations that we can work with. Just give me a sec. Let's turn on my green thing. There we are. So now, let me have a look here. So our sum to infinity equation is, where are we? So that's a over 1 take r. And our second term, term 2, which is negative 2.5, that is equal to basically a times r. So we've got here two equations, and because we've got two equations, we can just throw them in a calculator. So, and I'm going to use the correct letters. You could use x and y, but I'm just to avoid confusion, I'm going to do negative 2.5 equals AR. And then we've got, and the sum to infinity is 8. So 8 equals, and I'll just do one of those, A over 1 take R. And our unknowns are A, comma, R. There we go. And we've got two answers right away. We have an A equals negative 2, R equals 1.25, or A equals 10, R equals negative 0.25. Now, the question we want to ask ourselves is which one of these is correct? Now, one of the things we need to remember is that this sum to infinity is only valid in the situation where the r is less than 1. So here r is greater than 1. So we can completely discard this answer right here. It's not going to work for us. It's just going to give us a completely wrong number. This one, on the other hand, we start at 10 and our numbers are 0.25 or negative 0.25. So we want to find the sum of the first three terms. We could use our sum equation, but I'm actually just going to go, well, if the first one's 10, the second one is going to be that times negative 0.25, 10 times negative 0.25, that's going to be negative 2.5, obviously, which is, so we already had the second term. And then we multiply that by negative 0.25 again, and we get 0.625. We add those together, that plus 10, take 2.5, and that gives us 8.125. And that is our answer. So that's the sum of the first three terms. I'm just going to double check the answers. Yep, that's all correct. And so yeah, that's how we can do that. And you could have used the equation as well. The ClassPad does have a nice little e-activity that solves for a geometric progression sub. So we could have done that as well, just to show that here. We start with 10. Our ratio is negative 0.25. And the number of terms is 3. Let's find out if that gives us the same answer. Yep, 8.125. And just out of curiosity, if I do 100, we end up with an answer of 8, which is our sum to infinity, which is what we expect. So that's just a little bit to check as well, just as a bit of a sanity check. We could have put it in the infinite one as well, but I decided to just try a large enough number here that it would have converged to 8 there. And so it did. Okay, so let's look at question 15. This one's worth 12 marks, so there's a lot to it. So the function f is defined by this, where a, b, and c are constants. So we've got a cubic with a 1 on the first term. So we've got a graph. It passes through 0, 8 and negative 2, 0. 0, 8 and negative 2, 0. So it passes through those two. Has a local minimum at 2, 0. So that's a local minimum, which means that it's going to be a little curve like that. So if we want to sketch that, that is basically all we need to do. We've got those three there. We go that, and we don't know where it actually maximizes, but we don't actually care because we don't have that data yet. So this is worth 3 marks. It's just basically making sure we understand what's going on there. So just to check the graph, in the answers it does say you get your marks for getting that local minimum, which was at 2, the y-intercept and our root, and that we've got a smooth curve and that it looks like a cubic. And it also helps to have those little, I'll just draw that again, it helps to have those little arrows at the end. So try not to make it as much of a straight line as I am. I'm just actually going to try that again. We go like that, and in fact, remember that this 8 that we've marked there is not necessarily a turning point. In fact, it's very unlikely to be a turning point. So we could end up with a maximum on this side or this side, but you don't get marks because we haven't actually determined where that's going to be yet. So you won't get marks for where you put that maximum point yet, but that's probably what we're going to work out. So that's the graph. What's the value of A, B, and C? Now, to work out the values of A, B, and C, I'm going to use the roots that we've got here. And the roots that we've got are, oh wait, sorry, I got that a little bit wrong there. That is supposed to be on this side. Sorry, I had my root there at 1. It should have been at 2. Let's try drawing that again. Something like that. Doesn't need to be perfect, just sort of like a cubic. So what's my A, B, and C? So I know that it passes through that point there, and I know that it passes through, or it touches that point there, which actually tells me that what I've really got is x plus 2, because if x is negative 2, it ends up there. And we've actually got, when there's a turning point on the x-intercept, we've actually got that appearing twice. So that becomes x minus 2 all squared. And it's going to be multiplied by some number, but we don't know what that is yet. Fortunately, we've got this to work it out. So y is going to be a times 2. Actually, no, we do know what that a is going to be. A is going to be 1. And we know that a is going to be 1 because there is no coefficient there. But we could have worked it out as well because 2 times negative 2 times negative 2 is positive 8, which is already our y-intercept there. So we can now start expanding this. So I'm just going to do expanding one at a time. I'll do my one over there first. That's x squared. Take 4x plus 4. We then expand it again, x cubed. Take, so 4x squared plus 4x, and it's plus 2x squared, and lining these up makes it easier as well. Take 8x plus 8. What does this simplify to? We've got x cubed, and because I've lined these up vertically, it makes it easy to subtract them as well. So I've got minus 2x squared minus 4x plus 8. Now, let's double check that. Because we are in the calculator allowed section, I can just double check that I've got the right answer. It's always good to do, especially when we're doing a relatively complicated thing like this. Just a second, I'll put this back to default. There we go. So let's throw that in there, see what we get. And yeah, looks good. Passes through -2 and 2 and passes through 8 as well. So it looks like our sketch is pretty accurate as well. And I've just remembered, remember that your calculator is very powerful and can do certain things for you, such as transform expanding. There we are. We didn't even have to do all that maths. So the fact that the calculator expands things for you does help you out. And in fact, now we can say A equals -2, B equals -4, and C equals 8. There we are. Use a calculus method to determine the exact coordinates of the local maximum. So a calculus method would mean differentiation. So we want to differentiate that. Dy by dx equals 3x squared. Take 4x, take 4. And we want to find where that equals 0. So what's that going to be? So we got 3x squared, take 4x, take 4 equals 0. And we're in calculator allowed, we solve that. So what are we? 3x squared, take 4x, take 4 equals 0. And we'll just do the solver. What if we've got x is 2, which is what we expect, and -0.667, or x equals -2/3. Because we don't need that one there. So what's the exact coordinates? We put -2/3 into there. So we sub into equation. So that's our equation there. And what I can do is I can actually do my little given line, given x equals -2 on 3, 9.48. And let's see if there's a nice little 256. And that's what we have there. So let's just double check. Yep, so it's fine with that as an answer. It's also fine with doing the decimal as an answer, so we don't need to do it as a fraction if we don't want to. But we can sub that in, and we can also double check on our thing. Okay, so where's the maximum there? And that is 9.48 as we found before. Okay, so that's our answer there. Not too tough. Determine the coordinates of the point where the tangent to y equals f of x at 0, 8 intersects the curve other than at the point of tangency. So we want to find, first of all, we want to find the equation y equals mx plus c at x equals 0. So first up, we've got our equation of our differentiated one there. So that's going to be dy by dx was 3x squared, take 4x, take 4. And at x equals 0, that equals -4. So we've got something, so we've got y equals -4x, and we've already got the y-intercept, it's +8. So that's the equation of our line. So the way that I would do this is just do 4x or negative 4x plus 8. Throw that in there. Oh, I've lost my other equation. Let's throw that one in there too. There we are. Intersection. There's just the one and there's the other one. And that's at 2, 0 by the looks of it. So from sketch, also intersects at 2, 0. There we are. And that looks good. Let's just make sure. Yeah. So we could have put in the equation as well and solved from that, but there's no reason not to use the facilities of the calculator and say that you've done a sketch. So yeah, we just needed to work out. Now, it was quite obvious that the gradient would be negative 4 from that because everything zeroes out. The y-intercept was 8, so that one's a pretty easy 3 marks, but it is contingent on getting everything else right, unfortunately. Okay, next up we have a probability question. This one's a tough one. When a patient takes a pain-killing drug, the probability they experience some side effects is known to be 0.1. The doctor prescribes drug A to 2 unrelated patients. What's the probability that neither patient experiences some side effects? So the patient not experiencing side effects will be 0.9. 2 of them not experiencing side effects will be that times that, same one twice, which is 0.81. Now, the probability that one patient experiences side effects and the other does not, it could be either the first patient has side effects and the second one, so the first patient doesn't have side effects and the second one does. Or it could be that the first patient has the side effects and the second one does not. Same number either way, but we've got to add them together to get our actual probability of one patient experiencing side effects and the other does not. If we really wanted to, we could have modeled this as a tree diagram. So we had patient 1, side effects, no side effects. Patient 2, side effects, no side effects. Either way, where all of these are side effects with 0.1, 0.9, and so we would have needed to add up both this path, which is S and S bar, or S bar and S. There we are. The complement of S and S. So either way, there are 2 ways we can get it. We've got to add both of those together. Okay. Other pain-killing drugs are available. Of those who take drug A, 88% of patients who suffer some side effects will switch to another drug, whereas no patient who has side effects will switch. So if the doctor prescribes this drug to a patient, what's the probability the patient does not switch to another drug? Now I'm going to do a tree diagram. So patient, we start here. For those who take, so first up, what's the probability of side effects? It could be 0.1 for side effects, 0.9 for not. Now, if they get to here, they're not going to switch to another drug. That's 0.9. If they do if they do have side effects, that's side effects. That's no side effects. Let's get rid of that S. It's a bit confusing. And so 88% of patients will switch. Which means 12% of patients will not switch. So we could do this by working out this one down here, which is going to be 0.012. Add that to that, and that gives us 0.912. Or we could work out the other probability. Let's just Close that off. The other probability is 0.1 times 0.88. And we should do 1 subtract that number. Turn it to decimal. And that's 0.912. So we've got the same answer, whether we work out the probability going that way or whether we work out the probability going by adding the other two. Okay, so that's that one there. Just a sec. Come on. The doctor prescribes drug A to 3 unrelated patients. Determine the probability that at least one of these patients switch to another drug. So, the probability of one or more switching is actually the same as the complement of the probability that none switch. So working out the probability that none switch is actually quite easy because we already have this probability that that they're not going to switch. So it's just going to be 1 take 0.912 to the power of 3, which represents 3 different people not switching. So 1 take 0.912 to the power of 3, 0.241. Let's double check I've done that correctly. Yep, that looks good. So that looks, and so that's what I would have as my answer there, 0.241. That is my probability, or 24.1%. That is my probability that at least one of these patients are going to switch. And there we have it. So there we go. Lots of confusing little things to have to think about in this one, such as this idea or this sort of misshapen tree graph, which sort of does not have a second step down here, and realizing that there's 2 different ways that one patient could experience side effects and the other not. So there's lots of different ways you can muck this one up, unfortunately. But if we think about it methodically, we can get to the answer. Okay. The amount of water in a tank is W liters, and it varies with time T in minutes, modeled by this equation. So what kind of equation have we got? We've got an exponential that starts at 200 and gradually goes down. Now this T is a negative T, so eventually we would expect that to, what would that do? Actually, no, yeah, that would start off at, looks like it's going up, but we'll have a look at what happens. It looks like it does not start at 200. It'll start at 15 and gradually go up, because if T is 0, or maybe a bit higher, we'll find out what's going on. When T is 0, yeah. So when T equals 0, this whole thing becomes 1. 200 take 185 is 15 liters. After 15 minutes, or also I'm just going to draw a quick little 200 take 185, 1.2 to the power of, and I'm going to call it negative x. Draw that on there. And let's just have a look at the axes of this, because it looks like we're going to be sketching it. I'll just copy those. We have x goes from 0 to 45 by the looks of it. I'll give it a scale of 5. Y goes from 0 to, I'm going to call it 250, and give it intervals of 50. There we go. Where's the y-intercept? It's at 15, as we predicted. And where is, I can do a y-calc when x equals, so that was after, where are we? After 15 minutes. So I can put 15 in there. And that gives me, There we are, 188 litres. We'll just round that up. There we are. So it looks like it gradually sort of gets to 200. So we want to graph that. We start at 15. So that's going to be halfway between those two there. We found 15 is 160, 70, 80, 188. So we got that point there. At 45 minutes, it's going to be so close to, it's always good to find what's going to happen at our extremes. That's 199.9, so close to 200 that it doesn't matter. So we're going to have something that looks a little bit, try and copy that as best as you can. It's just an exponential that goes up like that. Now the lines are a bit hard to draw on my tablet, but you get the idea there. I'll just see what the points are worth. So you'll get a point for the y-intercept for putting down this point here that you've already worked out, that it's got an asymptote, and that you've got a relatively smooth curve. So you don't have to mark any more points other than what we've got going on there. And it doesn't need to be perfect, but we've got a general idea of the behavior of it. Now, when you're drawing this by hand, you're going to have an easier time than when I'm doing the tablet. So, over time, the amount of water in the tank approaches V litres. State the value of V. Obviously, it's 200 litres. And determine the time at which the amount of water in the tank reaches 99% of this value. Find V equals 198. That's 99%. I'm just going to use a G-solve, finding an X value because we know the Y value is 198. Um, 24.8 minutes. Okay, and there we go, and that's the correct answer. So we just need to, so that's an easy 2 marks, just sort of it's just a 2 mark, do you know how to use a calculator on a graph question. So yeah, that was pretty straightforward. Okay, now we've got one of these probability questions that where you've got to know your theory quite well and know your equations quite well. Two events, A and B, are such that the probability of A and not B is 0.2, probability of B is 0.5, and probability of not A and B is X. Now, it's often helpful to draw up a little Venn diagram or even a two-way table for these sorts of questions. But I'll start with a Venn diagram and see if that helps me out. So, probability of A and not B is 0.2. That is A only, that's 0.2. Probability of B is 0.5. That's going to be, what we sometimes do is we do a little thing like there, we do 0.5 in there. Probability of not A and B is X, which is B only, that's X. So, what we've got here, now let's just make sure we've got that. So those are our three events. What's the probability of A intersection B when X is 0.15? Well, this whole thing's going to be 0.5. So this in here is going to be 0.5 minus X. And it helps to put expressions for all the other bits that we're going to have in everything. So, and in fact, we've got 0.2 in here, 0.5 in there. That means we know that this is 0.3 outside there, which is also useful to know. So we've got expressions for all of the parts of our Venn diagram. And that's 0.35. What's an expression for probability of A and B in terms of X? We just did that. 0.5 take X. What's the value of X when A and B are independent? Independent means that that it doesn't matter what they are. So that means that A intersection B is equal, or the probability of A intersection B is equal to the probability of A times the probability of B. So what's the probability of A and B? That's 0.5 take x. We've got that from up there. What's the probability of A? It's 0.2 plus 0.5 take x. What's the probability of B? 0.5. No sense wasting time working out. Just so you know, I got the probability of A there by adding the only A part with the intersection part. So what I'm going to do is 0.5 take x equals 0.2 plus 0.5 minus x. I could simplify that, but I'm not gonna. Doesn't change the answer. So we've got that. 0.5 take x is equal to that. I can solve that. Usually if it gives me a clean answer, I've probably done the right thing. X equals 0.3. Cool. There we go. Nice and easy. So what's up next? That means that 0.5 take x equals 0. So x equals 0.5. Pretty straightforward. The only way that there is nothing in there is that all of our b is taken up in there. Probability of b given a is 0.6. So remember that probability of b given a is the probability of b intersection a divided by the probability of a. And we know that's 0.6. So what's the probability of b intersection a? We've already got that, or a and b, 0.5 divided by x. Or 0.5 minus x rather. What's the probability of A? We just worked that out before. It was, let's add these together, 0.7 minus x. Equals 0.6. Let's just solve that. And let's just draw that as a fraction. 0.5 minus x over 0.7 minus x equals 0.6. Solve. 0.2. They don't usually try and trick you with these. If you get a clean looking answer like 0.2, you're probably right. So yeah, there we have it. So we just needed to remember how we defined all these things, be a bit flexible in how we thought about algebra, and then in doing so, we should make this fairly easy to solve. Okay, there we have it. Okay, my favorite question in the test. Now, hopefully I won't struggle too much to explain this one, but anyway, a right circular cone of base radius 10, so we've got 10 centimeters there, and height 25, stands on a horizontal surface. We've got a cylinder of radius x centimeters and volume v centimeters cubed, stands inside the cone. Don't worry about this wording so much. Basically, we've got a cylinder inside this cone, and the circle here matches the outside of the cone there. So we need to find an expression for volume and show that it's this. This, I think, is one of the hardest questions in the test, if not the hardest. And fortunately, you do not have to solve this to go on to the next bit. So just to show that we don't have to solve this, let's assume we know this. Let's go to the next question. Volume is 25 pi x squared, take 2.5 pi x to the power of 3. Given that x can vary, what's the maximum value of v? So we want to differentiate that. dv by dx, that is 50 pi x, take 7.5 pi x squared. That's just doing that. and we want to find where that's equal to 0. So let's do that. 50 pi x, take 7.5 pi x squared equals 0. And let's do it in standard as well, just so that it's a bit easier to read. Okay, that looks good. X is 20 over 3. We can discard the 0 solution because when it's 0 it doesn't matter. So we put that back into our original equation. 25 times pi, pi x squared, take some 2.5 pi x cubed, given x equals 20 over 3. And now we do want our decimal 1163. And was it centimeters? Yep, centimeters cubed. Let's just double check I got that right. It's very easy to get these ones wrong. Yep, that's good. They rounded it to the nearest whole number, but it doesn't tell you where to round it. So that's what we get to. So the maximum value of V is that. Okay. So let's go back up to this one. Now we're showing that the volume is equal to that. So we don't have to do this. This is an extremely difficult question, I believe. But what we can do is we can cut this off like that. We know that this is 10 and this is 25. And we're going to have a way to get the radius in here, or x is going to be in there. Now, this is going to be some percentage of, so some percentage of this is going to be on there. So whatever percentage of the way across this is going to be the opposite percentage of this. So this is a quarter of the way. So this goes across by 2.5, which is a quarter of the way there. Actually, let's do 2. So this goes across by 2, which is 1/5 of the way. We're going to have 20 that goes down by there. So what I'm going to do is I'm going to say that, now how do I do this? I think we end up doing 0.25. Now, what was it? I always get myself tied in knots trying to reason this one. So x is, so let's say we've got, yeah. I'm drawing a complete blank on this one. Let's go back from it for a sec. So, so this height here, so height is going to be, so if we know an x, the height is going to be that x divided by 10 times 25. Not quite. I'm just going to look at the answers. So what they've written is h equal, or h, I did this in class before, honestly can't remember the way you did it, and so they say that h over 10 minus x equals 25 over 10, which gives us h equals 25 take 2.5 x. Don't know quite how they get that solution, but that's what they say. And I'm not going to waste time doing this because my mind's not quite working properly at the moment. But from that, volume is equal to pi r squared h, which is pi x squared 25 minus 2.5 x, which is 25 pi x squared minus 2.5, or cubed rather. No, that's squared. Minus 2.5. It's too late. There we are. Pi x, that's the cubed one. There we go. So 25 pi x squared minus 2.5 pi x cubed. Let me just see if I can intuit a way that this worked again. So if we had 10 times no, it's lost me. I've completely forgotten how I solved it, but I'm not going to waste more time on this because there's more important things to do, and I think this is a silly question anyway. Okay, let's go. So, next up, a fair six-sided die is numbered 1, 2, 3, 4, 5, and 6, and it's thrown n times until it lands on a 6. Probability that n is 3 is that. We've got to show that. So for us to get 3 rolls until it lands on a 6, you've got to roll not a 6, not a 6, and then a 6. That is equal to 25 over 216. 6 times 6 times 6 is 216. What's the probability that n equals 5? That's 5 on 6. Now we've got to roll the wrong thing 4 times, and then the right thing. And that ends up being, I'm just going to cheat, that's going to be 625 over 7776, or 0.0804. Okay, so it should be pretty obvious now that whatever n is, we're basically multiplying by 5/6 each time, and then we multiply by 1/6 at the end. Or, because the multiplication doesn't matter, we can think of it as a geometric series or geometric progression, where the expression in terms of n. So basically, the expression is so Tn is going to be 1 over 6 times 5 over 6 to the power of n minus 1. And basically this is a geometric progression where a equals 1 over 6 rather, and our ratio is 5 over 6. Here we are. So yeah, that's our answer there. Determine the probability that the first 6 is thrown in 12 or less attempts. What we actually want to do is to do a sum of the first 12 numbers for that. So I'm just going to throw that into my E activity because it's frustrating to try and enter all that normally. So we've got a GP sum. So our A is 1 over 6. Our R is 5 over 6. And our N is 12. Oops, it lost my numbers. 1 over 6, 5 over 6, and 12. So let's calculate that. Should be a number less than 1. Yep. And because this is worth 2 marks, it helps to do just write out our formula. So there we go, 0.888 or 8878, however many decimal points we want to put it. I'm fine with 3. It doesn't specify. So the probability that the first 6 is thrown in k or less attempts must be at least 99%. So we want to find 0.99 equals 1 over 6. 1 take 5 over 6 to the power of n over 1 take 5 over 6. N equals, okay, sorry. So let's work that out. We want to find that when that's equal to 0.99. Solve that. 25.25. We want to round that up. There we go. So recognizing that we need to round it up is probably where we get that. And yeah, I've got k equals 26 on there. And so that's the correct answer there. Okay, last question. Now, these are two graphs, f of x and g of x. And f of x is this, which is the parabola. And g of x is a straight line, 2x plus k. Now, what's the value of the constant k so that there's one solution to this? What we've got to do is literally put those, write this equation. 1 plus 4x take 2x squared equals 2x plus k. So, let's move that over. Oops. There we go. Okay, so let's rearrange this. We got negative 2x squared. We take 2x from both sides. So we end up with plus 2x plus 1 minus k equals 0. Now we want it in this form so that we can use our quadratic equation there. So now we have, the quadratic equation, we want to find where it's got one solution. So we actually want to use the discriminant. So if we use the discriminant, that's going to be b squared minus 4ac, and when it has one solution, we've got equal to 0. So what's our b term? That's 2 squared. What's our a term? Minus 4 times negative 2. And what is our c term? That is 1 minus k. We want that equal to 0. Let's simplify that a little bit. 4 minus or plus 8, 1 minus k equals 0. And I'm feeling lazy, I'm just going to throw that into the solver. And k equals 1.5. There we go. So the thing to bear in mind about this is that this is finding the intersection point. If I was to, so this is a line, k is the amount that is being shifted up or down. We want to find the point where it just touches there once. That's what one solution means of where f of x equals g of x. So we move k up, and it sort of makes a bit of intuitive sense. If it was up to 1.5, it would just touch at this point once. So when does it have no solutions? Well, if k is greater than 1.5, it won't touch the line at all, so there will be no solutions. So that's our final answer to that one. So, yep, that's what we've got there. And that's the end of the exam. I'm mildly embarrassed that I couldn't get my head around exactly how you're supposed to solve this one, because I know I've solved it multiple times before. But I'll have to have a think about that so I don't get caught out by this one in the future. Anyway, hope that was useful to you, and well, good luck on the exams. Bye.